Okay, and getting back to where, what I would like to have done differently, or not really done differently, just the types of things that I plan to put in this app as time goes by. I mean, it would be nice. Most of these types of applications will have a button that you can press to change them from day mode to night mode. And I kind of thought about that in the beginning. I could put two separate CSS files and then just have a JavaScript button that switches between them. And in doing my research, one of the things that I noticed is that most of these types of applications, they start off in day mode and then you press a button to go into night mode, which really just seems totally backwards to me. I mean, if you're out, your eyes have adjusted, they're dark adjusted, and you turn on a phone or an iPad or something like that, if it starts off in the bright mode, you're really going to destroy I mean, that puts you 30, 35 minutes again waiting to get your eyes adjusted right. So that was kind of one thing that I took off of this with my research. And then the other thing, so I remember having a conversation with Mary Ann and Jen at the same time. I think y'all were talking to us at the end of MIU. I don't know, it's been about 6 months ago, but one thing you were saying is, you really don't have to reinvent the wheel. And when it comes to applications like this, what this one actually will do, um, most of the stuff is written by MIT PhD guys, and it's not very nice looking, or you know what I mean. It's just it's there and it's very functional and it does what it's supposed to do, but it really doesn't have a good look to it. So I thought that was kind of a little wide open thing for me to get in there and do that. But the last thing is I did promise a separate video for what this is about and what it's going to do. And I never got around to making that either. So I'm just going to give you the 2-minute primer on astronomy and where this plays out. I have we'll start out with a German equatorial mount. What is a German equatorial mount? What's that all about? And telescopes can be mounted on several different types of foundations. And if you want to do astrophotography or anything like that, you really need a German equatorial mount. So to start at the beginning, if you don't know a lot about astronomy, that's if you think about a map, if you're going to get in your car and you're going to drive somewhere and you're going to look at a map and you're going to make corrections to the direction you're heading, north, south, east, west, or in today's world, if you're going to use navigation, you're going to be represented by a little button on the blue button or something on the road, and it's going to move as you go. But the sky really is just a map, and it's if you can imagine wrapping that around the Earth, and from our perspective, it spins around us. I mean, obviously, we all know in reality we're on the Earth and the Earth is spinning. So, but that map never changes, and so with that, if you look at things on that map, they're rather than north, south, and east, west. They're done in declination and in right ascension, and so where the German equatorial mount comes into play is if the Earth is rotating on its axis, and the axis is about 23 degrees, 23 and a half degrees from straight vertical. So if you take that telescope and you walk outside in your yard and you put it out there and you line that mount up exactly with the Earth's poles at 23 and a half degrees, theoretically, the entire sky is just going to spin around you in right ascension only. So, the next thing that comes into play is how fast do you make it turn, and that's really easy to figure out. But it's not. There's a few things that come into that equation that people don't think of, and the Earth spins 360 degrees in 24 hours, so you're moving at basically 1 degree every 4 minutes. So at first thought, you think, well, that's what I need to do. I need the thing to track 1 degree every 4 minutes. But if you do that, you're going to be a little bit off. And the reason for that, the first thing you're going to think is it's because of the leap year. But, it's got nothing to do with the leap year. And the easiest way to think about that is if you draw a line from the North Pole to the South Pole, and that line is straight over your head, that line would be called the meridian, which incidentally, if you point your telescope towards the meridian, you're going to get the best view of anything because you're shooting through the least amount of atmosphere. But um, in any case, if you think about the meridian, the sun crosses the meridian wherever you are every day at noon. And so theoretically you think, well, in 24 hours it's going to be noon again, but actually it's 23 hours and 56 minutes because you lose this 4 minutes, this magical 4 minutes that you lose, and that's the reason that the stars aren't always in the exact same place. They move just a little bit every day. And the reason for that is you have to remember that the Earth is traveling around the sun at the same time it's rotating. So if the sun hits that meridian at noon today, tomorrow the Earth will have traveled approximately 1 degree in its journey around the sun. So it's going to hit that 12 o'clock mark actually 4 minutes earlier. So once you get those things down, that the idea behind that, then it all begins to make sense. That's why every day each star is just a little bit further away or higher or lower in the sky, depending on what star it is you're talking about. And that's why you have to be able to line up the telescope perfectly if you want to see things. So, but it's a nice thing to achieve if you get that German equatorial mount exactly perfectly lined up. You can look through it and find Orion's Nebula or whatever it is that you want to see, and you can go sit down and 2 hours later go look through it again, and it's going to still be in there because it tracks 100% in right ascension exactly at that sidereal rate. So anyway, that's it. I hope everybody had a great week, and look forward to seeing you again in the next class. Thanks.